How are you doing tonight? Julian, can you hear me? We don't have audio.
Hello?
I will call.
Oh, I can hear you now.
Oh, you can hear me now?
Yeah.
Oh, what happened?
I don't know. I just changed. Oh my God.
Well,
Like under your speaker, it said like headphones, so I just changed it to speakers, and then I could hear you.
Ah, okay. Okay. So you had a headphone switch on yours. I don't even have that on my GoToMeeting. You're talking about on the GoToMeetings rectangle?
Yeah. Yeah.
And you have a headphone switch. Wow, I don't have that. I just have telephone and mic and speakers.
Oh, that's weird.
Ah, okay. So that's what was going on the other night then.
Yeah, I guess.
I'm glad we fixed it. I was just ready to call you. Because I remembered that I had to call you the other night.
Yeah.
All right. So, we're on our last session, right?
Yeah.
When's your final?
Next Tuesday.
Okay. So we left off on number 6.
Yeah.
Do you remember where circle C was?
It was the first one.
Well, that was circle, this is circle A.
Yeah.
This was circle B. No, excuse me. This was circle C.
Yeah.
And the question is describe the transformation between circle A and circle C.
Okay.
So first of all, how is it going horizontally and vertically?
It's going up 2, left 4.
To the, yeah, absolutely. Left 4, up 2. What else? Its radius is going from 3 to 2. In other words, not just a transformation. Because they're talking about circle A, which had a radius of 3, they're transforming it into circle C, which has a radius of 2. So you have something like this. That's circle A. And I'm going to move it to circle C, which is right there. So I'm moving it 4 to the left and up 2, but I'm also doing what?
Decreasing the radius by 1?
Yeah, I'm not sure. I guess that's called a shrink.
Yeah.
Or a dilation is really what it's called.
Yeah, dilation.
It's a dilation from, a dilation by 3/2. Because you're going from a radius of 3 to a radius of 2. So it's a dilation by, not 3/2, a dilation by 2/3. That's what it would be.
Very good.
All right. These formulas for the following 4 questions, probably want those on your note card.
Yeah, I have.
Okay.
Let me get my note card. I'll tell you what I have.
Well, you don't need to tell me, but what I'll do is as we come across a problem, I'll say that you need this on your note card.
Okay.
And then you can decide whether you've got the right stuff on your note card. I don't know what all should be on your note card, but I know at a minimum some of these more sophisticated formulas should be on there.
Yeah.
So the volume of a cone, the general formula. You always want to start with the general formula.
Okay. Is it pi r squared times height divided by 3.
Okay, good. In other words, it's base times height divided by 3, but that really is the area of the base. And the area of the base is pi r squared minus height divided by 3. Fill in everything. What do we have? Excuse me, not minus the height, times the height. So, what's the radius?
The radius is 12.
What's the height?
20.
Divided by 3. There's your answer. After you stick that in a calculator and come up with a number. Okay? The only hard part here is knowing that. And actually that's not hard because you get to write it. But let me point out one thing here. Volume, I've had a couple of geometry students and they want to say base times height divided by 3. And I take a little bit of issue with that because it's not quite the same as the normal base that we're used to talking about. If I say what's the area of a rectangle, you say base times height, right?
Yeah.
Well, this base is one-dimensional. That's measured in either inches, feet, centimeters, or whatever. This base up here, capital B, is the area of the base. Two-dimensional. That's going to be measured in square inches, square centimeters, square meters, whatever. So to call both of them base is a little bit misleading. This is definitely base times height, and a triangle is 1/2 base times height. That's also one-dimensional. But they use a capital B here to designate that it's the area of the base.
All right.
Okay? So just be careful of that when you're dealing with volume. What's the volume of a sphere?
4/3 pi r cubed.
Fill it in.
Okay, so r cubed. The radius is 12.
That's good enough. Go ahead and do that math. I just want to make sure you can do it. You got a calculator, right? You're always going to do this on a calculator.
Yeah.
Go ahead and do it.
Alright, so 1,728.
Is that the answer?
No, that's just 12 cubed.
1,728, and then I got to multiply that by 4/3 pi. There you go. Give your answer in terms of pi.
2,304 pi.
Yeah. Good. I presume she wants all answers in terms of pi. Am I correct? I mean, how often does she ask for it in a decimal?
Like never.
Okay, good. That's the way it should be. Volume of a cylinder. General.
Isn't it pi r squared times the height?
It's base times height. Capital P.
Base.
You were right.
Okay.
It is pi r squared times height. But if you're looking for a simple way to remember it, a cylinder is a prism. It's got the same circle on the top as it's got on the bottom. That makes it a prism if it's uniform throughout. And all prisms are the base times the height. So pi r squared for the base times the height. Okay, fill in everything.
Alright, so the radius is 2. And the height is 4. So 4 times, is it 16 pi?
A rectangular prism. What's the volume of a prism again?
Length times width times height.
Yeah.
Divided
Or
by
you
3.
could, no, not divided by 3.
Uh,
I could say it's the base times the height, right? The area of the base.
yeah.
All prisms are the area of the base times the height. Well, turns out that the area of the base is length times width times height.
Okay.
You weren't wrong when you said that, but it's all I'm trying to get to realize is that it's all prisms are the area of the base times its height. So in this case, it's 2 times 3 times 6.
All right.
What's the area of this going to be? Or the volume?
All right, so is it just base times height?
Uh-huh. But
it's
base times height because it's a prism. But what's the area of the base going to be?
Is it 2?
Well, hold on. That's a special kind of polygon. It's a hexagon.
Yeah.
How do we get regular polygons? That's something else you want on your card. Is the area of a regular polygon.
I have no idea.
Okay, it's 1/2 the apothem times the number of sides times the side length. Well, the only thing we know at the moment is the side length, right? It's 2 feet.
What's an apothem?
Well, we'll go through it
in
just a moment. But make sure you put this on your cheat sheet.
All right.
And then let's review how we get it. So, first of all, let's draw our hexagon. That's the apothem.
Okay, so the radius?
Well, it's not really a radius. I mean, if anything were going to be a radius, that would be a radius. Okay, it's called the apothem. It's the perpendicular measurement to one of the sides. Okay, this is obviously side length. The number of sides, you know, is 6. So we have N and S. What we don't know is the apothem, so we have to figure out the apothem.
Okay.
All right, so let's break this up into some triangles. First of all, what is the central angle going to be? How many sides are there?
6.
What's the total degrees when you go around a circle?
360.
What's the central angle here?
60?
Uh-huh. In other words, I can break this thing up into 6 triangles. All of them equal. So every central angle is 60.
All right.
Now, the apothem, if the central angle is 60, what's this angle right there?
30.
We know the side is 2. So what's the distance between there and there?
Wait, where and where?
We need...
1?
Side, and we're trying to figure out the apothem. Yeah, that's 1 right there. Okay. So now we know what we're dealing with. We're dealing with a 30, 60, 90 triangle.
All right.
Our standard. Whose side opposite the 30 is 1. What's the side opposite the 60 supposed to be?
twice it? 2 times it?
Square root
Oh,
3,
wait. No, yeah.
2.
Yeah.
Put this on your card. Put this triangle and put this triangle on your card, both of them, right next to one another, and label.
So 45, 45, yeah, okay.
Label them exactly the way I'm labeling them here.
1, 1, and then square root of 2. Right.
If you have these two triangles, well, you frequently are encountering triangles that are one of these two triangles, they're similar to it. They're not always these dimensions, but they're similar. Once you recognize they're similar, then you can figure out what the dimensions are. Well, in this particular case, the side opposite the 30-degree angle is 1. So what's the apothem?
1.
Look at the triangle I just told you to put on your note card.
Alright.
The side opposite the 30-degree angle is 1, so I call it my unit triangle.
Okay.
What's the side opposite the 60-degree angle? Because that's 60 degrees right there.
Square root of 3.
That's the apothem.
Okay.
Okay? So, our area formula is 1/2 the apothem times the number of sides times the side length. Well, we know.
So that's for area of a polygon?
I'm sorry, what?
That's for the area of a polygon?
Yeah, all polygons have this formula. If you know the apothem. Now, in this particular case, they did not give us the apothem. We had to calculate it. Most of the problems where you have a polygon as one of the bases, they will usually give you the apothem. But it doesn't matter. As long as they give you one of these dimensions, you can figure out the apothem. In this case, the apothem is square root of 3. How many sides do we have?
6.
Each side length is?
2. 8.
So the area of this polygon, the 2's cancel, and we get what?
So
what's square root of 3 times 6? It's generally written as 6 square root of 3. Okay, now let's go back to our volume. Our volume is the area of the base, which we just calculated, times the height or thickness.
Okay.
So what goes in for both of these?
So the base is 6 root 3. And the height is 5.
What's that?
That is 30 root 3.
Alright.
Okay.
You know this stuff. I mean, and when I say that, I mean, when you answer something that you know, don't put a question mark at the end of it like you're doing. When you say 30 root 3, it makes me think that you don't really know it. And I really think you do know it. Okay? So having a little more confidence in your answer actually goes a long way. I'm telling this to a lot of students when particularly when I'm tutoring students on ACT or SAT. I get a lot of this where they don't trust their answer and they always give me their answer with a question mark, and 95% of the time they're correct. And so it's helpful if you know you're correct.
Yeah.
If you know what I'm saying.
Yeah.
All right. 17.
Alright, so
tell me what my picture is. What should those be labeled?
okay, so
I'll call them X. No, I'll call them X, Y, and Z. Tell me what they are for this word problem.
alright, so it says the string length is 140 feet.
Okay.
And it's 90 feet off the ground.
So what is 90? Which variable? Here's the kite right up here. Here's the person down here.
Alright. So 90 feet is Z, I think.
What would that be? Have you ever flown a kite?
Yeah.
Okay, well think about when you're flying a kite.
Okay.
The length of the string is going to be Z.
Yeah.
Right? Got to be. What's the height off the ground? Which variable?
Y?
Yeah, that's what's 90.
Okay.
They want to know the kite is tethered to the ground. What is angle theta? What is the angle made between the ground and the string?
Okay.
What trig function relates 90 and 140?
Let me write out SOHCAHTOA real quick.
Okay, put that on your card.
Yeah.
SOHCAHTOA.
Alright, so tangent?
Tangent is TOA.
Yeah.
Which is opposite over adjacent. Whenever they talk adjacent, they mean the side that's adjacent that's not the hypotenuse.
Yeah, so it's sine.
Okay. Sine is opposite over hypotenuse, and that's what we're looking at here. So I could say, if I wanted, that the sine of theta equals 90 over 140. But if I'm solving for theta, then theta equals what? Remember, when you're solving for angles, you always are going to use the inverse.
Oh yeah, the inverse cosine.
No, not the inverse cosine, the inverse sine.
The inverse sine.
In other words, it's got to be the same thing. If our picture tells us that the sine of theta is 90 over 140, then to solve for theta, we got to take inverse sine, not inverse cosine. It's got to be the same trig function. These two mean the same thing. This is an if and only if. If the sine of theta equals that, then theta equals the inverse sine of that ratio.
Okay.
Just always remember that when you take trig functions of angles, you get ratios. You get numbers.
Yeah.
Which means that when you take inverse trig functions of ratios, you get angles. So if you're trying to solve for an angle, you need to take inverse trig function.
Okay.
So what's the inverse sine of 9 over 14? Do you know?
Do I need a calculator to do it?
Yeah, you do.
Alright.
In other words, that's not a standard Pythagorean triangle. Not a 3, 4, 5 or a 5, 12, 13 or any of those.
Alright, it's 40.005.
Alright, we'll round it off to 40 degrees. So that's our picture so far. That's all we know. And B, if the kite were to fall, assuming it falls in a vertical line, how far would Kate need to walk to pick it up? What are they asking for?
For X.
Okay. Got two ways to figure out X. It's a right triangle, so what's one way?
Pythagorean Theorem.
Good. What's another way? What trig function relates X to either 140 or to 90? You can do either one.
Alright, so cosine?
Yeah, so what can I say? What equation can I write?
Alright, so cosine of What do you call that?
You're always taking trig functions of angles.
Okay.
So it's the cosine of that angle.
Yeah. Cosine of 40 degrees.
Equals what?
Adjacent over hypotenuse. So
Which is what? Yeah.
x over 140?
Correct. Which makes x equal to 140 times the cosine of 40 degrees. Remember, that's just a number.
Yeah.
So go ahead and get that number.
All right. .766.
Now you got to multiply it by 140.
Okay. 107.24.
That's how far she'd have to go to pick her kite up.
Okay.
In other words, is all they've asked you to do is to solve that triangle. Notice that they only gave you 2 pieces of information. Actually, they gave you 3. They told you that that was 140, that was 90, and this angle here is 90.
Yeah.
So they're always going to give you 3 pieces of information. One of them may be implied, and that's the 90-degree angle.
Yeah.
But you can't solve a triangle unless you have 3 pieces of information. Then you can solve for everything else. I can solve for this, I can solve for that, I can solve for that. Now I've completely solved that triangle.
Okay.
All right. 18. How are we going to solve 18a?
Alright, so shall we solve inside the triangle first?
Well, what do we have? We have a right triangle, first of all. That's helpful. In fact, I think that's all you're going to get in geometry is right triangles for trig.
Okay.
So the only thing we need to do is relate this angle, x and 12. What equation relates those 3 things? What relates x and 12? Which trig function?
Tangent.
Okay, so what can I say?
So tangent of 37 or 53?
53.
Alright, so tangent.
We could have done 37 actually, but 53 is what we're seeing.
Okay.
So what does the tangent of 53 equal?
12 over x.
What's your note say?
Opposite over adjacent.
What's the opposite to 53?
Oh, I was thinking 37, x over 12.
All right. The reason this is easier is because if we're going to solve for x, we only have to do one thing. We have to multiply both sides by 12.
Yeah.
Okay? And that gives us our answer in one step.
All right.
Now, to go back a step, you were focused on that 37-degree angle right there. Well, I could have said the tangent of 37 degrees equals 12 over x, right? And that would have been correct. And I would have still got the same answer for x. But notice that the math is harder here. I got to multiply by x, and then I got to divide by the tan of 37 to solve for x. So I got to do 2 steps here. So whenever you can get your unknown, the thing you're trying to solve for, in the numerator, like we have it at the top, that's better. It's going to be easier to solve. It's only going to be a 1-step solution, not a 2-step. So just keep that in the back of your mind. Eventually it'll become kind of second nature. But in general, with these problems, you only need to work with the angle you're given. You don't need to figure out that other angle. Okay, so in this one right here, work with this 60-degree angle. What relates x and 17 with this 60-degree angle?
Alright, so sine of 60 degrees
Good.
equals x over 17.
Like that confidence. So x is equal to what?
Alright,
You said that like you believed it, not like you were questioning it. You know what I'm saying?
yeah.
And that's what you need, is you need confidence on these. You need to know what you know.
So x is equal to 14.7.
Yeah. 17 times the sine of 60 degrees, and that sounds about right, 14.7. Okay. Do the bottom one. What relates those three things?
Alright, so cosine.
Tell me the equation.
So cosine of 51 degrees equals 10 over x.
Okay, good. That's okay that x is in the denominator. It just means it's going to take 2 steps to solve. So what's the next step in solving this algebra? So what's x going to be?
By 10.
What's that?
You have to divide by 10?
Well, not the first step. The first step is you get rid of the denominator.
Okay.
So how do I get rid of the denominator?
You times it by x.
Okay, so now I have x cosine of 51 equals 10. Trying to solve for x. So what do I got to do now?
So I find the cosine of 51.
Well, let's just do the algebra.
Okay.
And divide both sides by the cosine of 51 degrees.
Okay.
And that solves for x. And then you can put this in your calculator to get an answer.
Okay.
It's going to be some number greater than 10. What is it? Make sure you can get it.
Wait, greater than 10?
Yeah, because the denominator has to be less than 1. In other words, the cosine of an angle can never be greater than 1. So the cosine of 51 degrees is going to be a number less than 1. And if I divide 10 by a number less than 1, it gets bigger.
Okay, I got... Wait, so it's the cosine of 51 divided by 10?
No. 10 divided by the cosine of 51.
Okay.
But you might need both parentheses. In other words, I want to make sure you know how to get that number, get that answer on your calculator.
15.89.
That sounds right. 15.89. Okay. Very last one. Call that theta, what they're looking for.
Okay.
Right angle again, right triangle, so we can use our trig functions. What trig function can I write?
Alright, so you could write adjacent over hypotenuse. Cosine of theta equals 20 over 23.
Very good. So what's theta equal?
So
It's the expression. I don't care what the number is. What's the expression?
So theta equals the cosine
Inverse. Remember, when we're solving for angles, it's always going to be an inverse trig function.
Alright. So inverse of 20 over 23.
Good. Look that up on your calculator.
29.5.
That's right. 29.5 degrees. Okay. Let me open the second page that I have here. Let's see. I forgot. Let's see. We did some of these already, didn't we?
Yeah, but remember, like, we couldn't figure that
I
one out.
still think it's a typo. I do.
Yeah.
I absolutely think it's a typo. We did 1 through 7, so we need to pick up 8 through 12.
Yeah.
Yeah, that one's not doable the way they've spelled it out there. I might be wrong. If you go talk to your teacher and you prove me wrong, I'd appreciate you telling me. I may have missed something about that problem, but it looks like a typo to me. All right, let's look at 8. Let's always draw a picture. I mean, it never hurts. Unless time is a huge thing, let's draw a picture here. They're giving us 2 coordinates that are the endpoints of a diameter of a circle. So if I can pinpoint those 2 coordinates, I'll connect them. That's my diameter. I can then draw the circle.
Okay.
So the first point is where?
0, 2.
Where is that?
Just up 2 from the center.
Okay, right there. So that's point A. Where's B?
4, 8, so over 4, up 8.
Okay, we'll call it there.
Okay.
When you draw your picture, it's not absolutely vital that it be perfectly correct. All it kind of has to be is half correct. In other words, that's probably not 8 units up. If this is 2 units up, that's not 4 times that many. But I didn't have any room to fit it, so I just drew it there and labeled it that. Now I connect that, that's the diameter of our circle. Well, we know how to draw our circle now, right? It can only be one way. That's the only way you can draw this circle, if that's its diameter.
Okay.
Okay, this point is 0, 2. Where's the middle of the circle? Find the center.
Okay, so maybe 2, 4.
2 is correct. What's halfway between 2 and 8?
6.
Is it?
Wait. No.
Find a number. Just keep trying. And find a number that's equidistant from 2 as it is from 8.
Alright, so 5?
Let me give you, that's correct, but let me give you the easy way of doing it rather than the hard way, which is the way you did it.
Okay.
Add the 2 numbers together, divide by 2.
Okay, wow.
And then check to make sure that 5 is 3 units from 2 and it's also 3 units from 8.
Yeah, okay.
Okay. Now the length of the diameter. Well, what do we have to know for that?
AB.
Right, but it's the distance formula.
All right.
There's a distance between 2 points. Remember what it is?
I don't.
If I say, think the Pythagorean Theorem. In other words, whenever we're looking at 2 points in the xy plane, almost always those 2 points are equal to the hypotenuse of the triangle that I would draw like that. So we know that the hypotenuse is equal to the square root of the sums of the x squared plus y squared, right? That's what the Pythagorean theorem says. Well, in this case, it's not x, it's the difference of the x coordinates. So it's x2 minus x1 squared plus y2 minus y1 squared.
Okay.
So that's the distance formula. But that's pretty complicated looking. A lot of people have trouble memorizing that. But not if you remember that it's the hypotenuse of that right triangle. Remember that when I have a right triangle, if I have A, B, and C, well, C is equal to the square root of A squared plus B squared. That's the Pythagorean theorem. Well, the distance between 2 points is the hypotenuse of the triangle. So it's the Pythagorean theorem, essentially.
Yeah.
So in this case, that distance is equal to what? What's x sub 2 minus x sub 1?
So 0.
Take the bigger number minus the smaller number.
Alright, so 4. Like, what does the of 2 mean, like? You say, like, x of 2 and x of 1. What does that mean?
That means one x coordinate minus the other x coordinate.
Okay, so just 4 minus 0.
So that's 4 squared.
Yeah.
Plus
8 minus 2.
6 squared.
Which is 6 squared, yeah.
Okay, so that's the square root of 16 plus 36. Square root of 52. Can we simplify that answer? Because that's not simplified.
Okay,
Is 52 divisible by any perfect square number?
I think so, yeah.
It's divisible by 4.
4, yeah.
So I could write it as square root of 4 times square root of what? It's the other factor. 4 is one of them. In other words, what's 52 divided by 4?
52 divided by 4. 13.
Okay. Now I can pull this square root of 4 out as a 2. Square root of 13 I can't simplify anymore. That's the length of the diameter.
Alright.
Okay. So that answers their second question. The length of the diameter. Write the equation of the circle. Give me the general equation of a circle, and if you don't, this is something else that you want on your note card.
Alright. Oh, I know this. But I don't know if I remember it.
Okay, this is what it is. Put this on your note card.
Okay.
What do H, K, and R mean?
Height.
No.
Oh.
H and K are the X and Y coordinates of the center of the circle.
Okay.
And maybe you need to put that on your note card. What is R? It's the only dimension on a circle that really matters.
Is it the
Radius.
The radius, yeah?
Yeah. So, in our case, we know H, K, and R. Right? We know the center. There's the center. We just figured out the diameter, so we know the radius is half this.
Yeah.
What's half of 2 root 13?
So
I multiply that by half.
Okay.
The 2's cancel, and you got just root 13.
Yeah. Okay.
So the radius is root 13. So I'm ready to write the equation of a circle.
Yeah.
My center was at 2, 5. So h is 2, k is 5, and r is root 13.
Okay.
So what's the final equation?
Alright, so x minus 2 squared plus y minus 5
Squared.
equals square equals 13.
Uh-huh. Very good. That's a good problem. Really a good problem. You have to know so many things to solve that problem. Let's look at what we had to know. First of all, we had to know how to find the midpoint between 2 points. That's pretty easy. Just take halfway between the 2 points.
Yeah.
Halfway between the x's, halfway between the y's. You always get that by adding them together, dividing by 2. In other words, notice that 2 is 0 plus 4 divided by 2.
Yeah.
Okay? Second thing we had to know is the distance formula to figure out how long this diameter is. Third thing, we had to know that radius was half the diameter. And fourth thing we had to know was the general formula for a circle.
Yeah.
Yeah, make sure if you write these general formulas on your card that you know what the letters stand for.
Alright, so H stands for
X coordinate of the center.
alright.
K stands for the Y coordinate of the center. And R is the radius of the circle.
Okay.
The area of that triangle.
Okay, so is it 1/2 base times height?
Say it with confidence.
1/2 base times height.
So what's the area of that triangle?
So 4 times 6 divided by 2. That's it.
What is it? Yeah. Give me an answer.
12.
Uh-huh. This is not Jeopardy.
Okay.
Okay? Have you ever watched Jeopardy?
Yeah.
You have to state your answers in the form of a question.
Yeah.
This is not Jeopardy. I don't want you to state it in the form of a question. I want you to give me the answer. Okay?
Yeah.
All right. Second one. We're finding the area of a trapezoid. What's the general formula for the area of a trapezoid?
A plus B divided by 2 times the height.
Well, it's not A plus B. It's base 1 plus base 2 divided by 2. That gives you the average base times the height. In other words, it's not that different from a rectangle. A rectangle is base times height. But with a trapezoid, we have 2 different bases. So we got a base 1 and we got a base 2. And the height that's referring to is that height right there, the vertical height. Okay? So we got a couple things we need to figure out with this trapezoid because they didn't give us the vertical height.
Yeah.
So they gave us this base is 16. They gave us this base is 26.
Yeah.
And since that's 13 and that's 13, it's a isosceles trapezoid, meaning it's like that. So what's this distance right here?
All right, so
it's the same distance as this distance over here.
Okay, so is it 5?
Yeah, because it's isosceles. That's only with isosceles trapezoids, and isosceles trapezoids, these two sides have to be the same. So yeah, that's 5. And I don't care about that one over there. I only need that height one time.
Yeah.
So what's that height right there?
Is it 5 times 13?
No, this is a right triangle.
Okay. So
What kinds of right triangles do you have to know? You have to know a 3, 4, 5. Write that on your card.
Okay.
What's the next one above that? Put that on your card. 5, 12, 13.
5, 12, 13.
Since we're looking at a 13 and a 5, this has to be 12.
Okay.
Now we have the height. So now we're ready to figure out the area.
All right.
What is it?
So,
in other words, fill in each of these. Don't just give me an answer. Give me the B1, the B2, and the H, and I'll write it, and then we'll simplify it.
all right. So 16 plus 26.
There you go. That's what I want. Yeah.
Divided by 2 times 12.
Right. I don't care what that answer is, but once you get to this point, you got it.
All right.
The area of the circle in C.
Pi squared.
What's the area of that circle?
All right. So 25 pi.
Good. In 10. Another hexagon.
Yeah.
And the only thing they're giving us is that. Well, we did a hexagon that a side length of 2 already, right?
Yeah.
Okay. So remember how we do it? We need the apothem. How am I going to get the apothem? Let's see if you remember how we did it.
All right. So
First of all, let's write the general formula of the area. Is this on your card?
yeah. So 1/2 of A times N times S.
Okay. Well, we know S, we know N. The only thing we need is the apothem.
Okay.
Question is, how do we get it?
Yeah. That is a
All
question.
has to do with these triangles. That angle is a central angle that is bisected by the apothem. So if I can figure out the central angle, then I can figure out that tiny angle at the top of my left triangle there.
Yeah.
Once I can figure out what this tiny angle is, well, I know what that length is. What's this length right here?
1.
Correct? So if I know this angle, I can use trig to figure out the apothem.
Yeah.
So what's the full angle?
60?
Yeah, because there's 6 of these triangles inside of a hexagon. If it was a pentagon, there'd only be 5 of them. You'd have to divide 360 by 5 to get that angle.
Yeah.
But with this case, that's 60, which makes this 30. What's the apothem? Look at your unit.
30, 60, 90.
Okay, look at your unit triangle. You should have that on your note.
Yeah.
What side's opposite the 30-degree angle?
1.
Same with this triangle. This triangle we're looking at here is congruent with the triangle on your card. It's not just similar, it's congruent. What's the apothem?
Root 3?
Correct. So it's 1/2 times root 3. What's the rest of it? How many sides?
6.
Length of each side?
2.
2's cancel. You get 6 root 3.
Okay.
That's the area of that hexagon. 6 root 3.
Okay.
Okay? Well, we're not going to quite get through it all, but we're going to come close. Shaded region problems are always what?
I don't know.
Subtraction problem.
Subtraction, yeah.
I had a geometry student the other day that gave me my very first case in 7 years of a shaded region problem that was not a subtraction problem. But that was honors geometry, and it was the highest degree of difficulty. So you can count probably on every shaded region problem being a subtraction problem. Well, what do I need to subtract?
360.
Now, hold on. When I say subtraction, I mean it's the outside area minus the white area.
Okay.
What's the outside area? This measurement, is that a 6?
Yeah.
Okay, so what's the area of the square?
So 12 times 12?
144. So, let's write it. The area of the shaded region is equal to the area of the square minus what? What are those two things right there?
Half circles?
So together they make a circle.
Yeah.
So I could say 2 semicircles or just the area of the circle.
Okay.
And we have all the information we need. So the area of the shaded region, what was the area of the square again?
144.
What's the area of the circle?
360.
What's the formula for area of a circle?
Pi r squared.
What's the area of this circle? Or
Alright, so
2 half circles?
wait, so what's the radius though?
Well, what is the radius?
Is it 6?
Uh-huh.
Alright, so
6. In other words, that 6 goes to the center of that semi.
yeah. So 36 pi.
There's your answer.
Alright.
That's the area of the shaded region. 144 minus 36 pi.
Okay.
In other words, we don't have the math to figure out the area of this shaded region. That's an odd-looking shape. We don't have any idea what the area of that is. I know the area of squares, and I know the area of semicircles. So if I can turn it into a subtraction problem, it's a piece of cake. It's the area of the square minus the area of the circle. And all shaded region problems are kind of like that. You're given a shape that you don't know how to do, but you can do it based on subtraction.
Okay.
Any solid figure that has congruent bases, what's that another name for?
I don't know.
A prism.
A prism?
That's what a prism is.
Okay.
Any solid figure that has bases at each end that are the same.
Okay.
So what's the volume of any prism?
It's just the area of the base
Capital B.
times the height.
Exactly. Times, it's not always height, it's the distance between the two bases. Right?
Okay.
In other words, we had a problem earlier where we were looking at a hexagon thingy. This thing right here. Okay? In other words, the 5 feet is what you call height.
Yeah.
It's the way it's positioned. It's not height. It's depth or length or whatever you want to call it. But it's the distance between this hexagon and the hexagon that's at the back end that you can't see.
Yeah.
So it's the area of that hexagon times 5, times the thickness of it.
Okay.
All right. Well, I guess we'll have to leave it there. We got number 12.
Okay.
And it's too bad because I like these problems here. I'd like to see you do some of these. Notice that every problem of the next 6 is one of those special triangles. In other words, that thing is similar to the 45-45 you have on your card.
Yeah. Figure
out what the ratio is and figure out the sides based on that. That thing is similar. That's similar. That's similar. Each one of these is similar, and each of those is similar to either the 45-45 or 30-60. Once you figure out the similarity ratio, then you can go from there.
Yeah.
Okay?
All right.
Good to go?
Yeah, thank you.
You're welcome. Have a good one. Good luck on your test if I don't talk to you again before then.
All right, thank you.
Bye-bye.